going to talk about IV solutions, the different type of solutions, isotonic, hypotonic, and hypertonic. But first, we need to figure out what's going on inside the cells for each type of solution. Draw out my little cells. I'm going to label this hypertonic. Isotonic. And hypotonic. Alright, so let's figure out what's going on in the cells for each solution. Hypertonic solution. I have so much concentration on the outside, and there's so little intracellular. So, by osmosis, we're going from lowest concentration to greater concentration. So we're going outside, shifting out to the extracellular. So ICF to ECF, extracellular fluid. And that's going to make my cells shrink. Isotonic, I have the same equal amount in the intracellular to the extracellular, so we are equal. No changes to cell shape. In hypotonic, I have so much of the solute intracellular and this tiny amount on the extracellular, so everything is going to go from extracellular to intracellular. Which could cause the cell to burst. Now, which fluids do what? D5LR, D5 half NS. Let's see here. D5NS, 3%. So a good way to remember this is that you're looking at higher percentages for hypertonic solutions. Isotonic, we have your normal saline, LR, D5W. I'm going to star this because it is a special type of solution. And hypotonic, we'll do half normal saline. Okay. The reason for why did I star the D5W? It is because when D5W enters the body. It's quickly metabolized by the body, and what's left is only the H2O. So, when it's just in the bag alone is isotonic. But once D5W enters the body, it becomes hypotonic. Let's see here. Uses. What color can I use for uses? Let's see. Half normal saline. It's pretty much a fluid replenishment. Choice for diabetics when they're NPO. D5 half NS is the most common post-op fluid to be used. D5 NS, I'm going to make this like a super yellow. Okay, you guys can't even read that. Fluid overload. Basically, watch out with your hypertonic solutions, because now you're shifting from intracellular to extracellular, which causes an increase in vascular system. So now you're looking for fluid overload, renal failure, cardiac patients, because they can't get it out, or you're going to compromise the heart even more. The only solution that could be used for ICP is mannitol. This is super important. This is on every single test or question known to man, even NCLEX. This is going to be on the Fishbone CBC. This is going to be your hemoglobin, 10 to 16, depending on the facility you work at, and if you're male or female. 10 to 14 for female, 12 to 16 for male. Your hematocrit, 35 to 45. This is going to be your white blood cells. Oops. $4K to $10K. And your platelets. 145 to 450K. Let's start with the white blood cell count, your WBCs. With neutrophils, never neutrophils. There will be a bacterial infection. Let lymphocytes, those usually mean viral infections. Me, monocytes, chronic infections like TB. Eat, eosinophils, parasites. Beans, basophils, this is associated with increased white blood cell count, so never let me eat beans. Neutrophils, increase in neutrophils indicative for bacterial infection. Lymphocytes, viral infection. Monocytes, usually a chronic infection like TB. Eosinophils, parasitic, ew. And B for basophils, bee stings or an allergic reaction. If we're looking for causes of low white blood cell count, think chronic. Autoimmune, leukemia, chemo, and aplastic anemia. Let's pick green. For your H&H, we're usually monitoring for bleeding or fluid loss. Platelets, a high count of platelets is a chronic condition like cancer. Low platelets is an acute episode due to sepsis, bleeding, and liver, like binge drinking. I'm going to start off with the Fishbone Diagram. And then for the second part, I'm going to go over the signs and symptoms as well as causes for each electrolyte changes. So your Fishbone Diagram is also known as the BMP, Basic Metabolic Panel, or your Chem 7. Basically, your BMP is the collection of labs evaluating the current electrolytes and kidney function of your patient. It could be done daily or in acute situations. At PMH, we usually do daily lab draws at 4 in the morning. I'm going to draw out my fish. Start off with his spine. Give him some ribs. And of course his tail. Sodium 135 to 145. Potassium 3.5 to 5.1. Chloride 95 to 105. Carbon dioxide 22 to 28. BUN, don't ever say bun. BUN 7 to 24. Creatinine 0.7, 1.4. Glucose 60 to 110. I would consider these fasting lab value range. If my sodium's high, high and dry. Low sodium, that's an uh-oh. Watch out for seizures. If my potassium's high, dump it. Meaning literally dump it. Common medication that could be used is lactulose to basically dump it out. Look out for EKG changes. If it's low, definitely replace, because that also has EKG changes. Low respirations that can lead to coma. Chloride and CO2, you basically have to find out where else this is happening in the body. Is it respiratory or metabolic? BUN and creatinine, for both, you need to determine, is it an acute or chronic condition? For example, if BUN and creatinine are high, it could be either. It could be end-stage renal disease, that's chronic, or it could be a dehydration episode from running outside or a heavy workout. That would be an acute episode. If my blood sugar is high, well, am I type 1 or 2? Do I have an infection? Am I on steroids? If it's low, well, uh-oh. Treatment is dextrose, apple, or OJ, and of course something to eat. Another lab skeleton is your PT, PTT, and INR. Let's draw the Mercedes sign. PT, PTT, INR. Now we can draw a Christmas tree. calcium, AST, ALT, protein, albumin, phos, and Billy. Oh, probably help if I wrote out the values. 8.4 to 10.2, 0 to 35, 0 to 35, 6 to 8, 4 to 6, 30 to 120, and 0 to 1. Your ABG little tree. 1, 2, 3, 4. pH, PaCO2, PaO2, and your bicarb. Seven 7.35 to 7.45, 35 to 45, 80 to 100, and bicarb is 21 to 27. It would help if I put the PT, PTT, and INR lab values. Let's see, PT is 10 to 13, 30 to 40, 45. INR is 1 to 2. I'm going to do a brief introduction of ABGs. You'll get more into it with third and fourth semester. And draw out my skeleton. 2, 3, 4. Is your pH 7.35 to 7.45. PaCO2 is 35 to 45. PaO2 is 8100, and your bicarb is 22 to 26. So your CO2 will determine if it's a respiratory issue, and your bicarbs will determine if it's a metabolic issue. For CO2, if it's on the lower end, it is alkalotic. Higher end, it's acidic. For your bicarbs, it's the opposite. If it's the lower end, it is acidic. Higher end, you're pushing towards more alkalotic. So, if my pH is low with a high CO2, but my bicarbs are normal, well, I have a low pH that is acidic, a high CO2 that is respiratory acidic. So therefore, I am in respiratory acidosis. If my pH is high, my CO2 is low, my bicarbs, HCO3, are normal, pH is high, so it's alkalotic. CO2 is low, so it's alkalotic. So therefore I am in respiratory alkalosis. If my pH is low, CO2 is normal, and my bicarbs are low, alkalotic, and because we're dealing with HO bicarb change, it is now metabolic alkalosis. No. It's not. Boop, boop, boop. I retract what I said. pH is low, CO2 is normal, bicarbs are low. Low pH is acidic, bicarbs are low, so it's acidic. And since we're dealing with bicarbs, it is now metabolic syndrome, so it is now metabolic acidosis. Forgive me guys, it's like 10:30 at night. Let's see. My pH is high, my CO2 is normal, my bicarbs are high, pH is high, so it's alkalotic, bicarbs are high, alkalotic, changes in bicarb, so it would be metabolic alkalosis. I'll go ahead and do like a sample problem. So our pH is 7.29. Our PaCO2 is 52. And our bicarb is 24. So according to our pH range, it is well below, so it is acidic. PaCO2 is on the higher end, so it's acidic, and we are in range with the bicarbs. Therefore, it is respiratory acidosis.